Hello students, in this video we'll see an example of converting an integral from rectangular coordinates to polar coordinates. Let's find the integral from 0 to 2, the integral from negative the square root of 2x minus x squared to positive the square root of 2x minus x squared dy dx over the square root of x squared plus y squared. Now this integral is an absolute mess in Cartesian coordinates, so however I see square roots of x squared plus y squared, that suggests we can change this to polar coordinates and see that that might be helpful. So let's first sketch this region. So let's look at these y limits over here. The y limits of integration, y, are plus or minus the square root of 2x minus x squared. If I square this, I have y squared is equal to 2x minus x squared. And we can see this is the equation of a circle. In fact, what circle is it? It's y squared plus x squared minus 2x, and then I'll complete the square by adding 1. And so now I see that this is a circle. X minus 1 squared plus y squared is equal to 1. So now we see that this is actually just a polar region, right? So it's a region. There's the x-axis, there's the y-axis, and I have a circle centered at 1, 0 of radius 1. There we have it. There's our polar region. Okay, so we see in this polar region the angle is going between negative pi over 2 and pi over 2. So my angular variable in this region is going between here and here. So my theta is going to range between negative pi over 2 and pi over 2. And the r is going to go from what? It's going to go from 0 up to this circle. The radius is always going from 0 up to the circle in this region. So what is the equation of that circle? Let's find it will be in polar coordinates. Well, let's take a look over here at this equation. This is going to tell me that x squared plus y squared is equal to 2x. Now this is the same thing as saying that r squared, because x squared plus y squared is r squared, is equal to 2r cosine theta. Cancel an r, and I can conclude that on the circle, r is equal to what? 2 cosine of theta. So I can change my problem into polar coordinates now, because I know that r goes from 0 up to this polar curve, 2 cosine theta. So let's change the polar coordinates. So if we change our integral to polar coordinates, this will become the integral. The angular variable is from negative pi over 2, so this will be equal to pi over 2. Then I integrate from 0 to 2 cosine theta. And here's where the great simplification comes in. X squared plus y squared square root is a 1 over r. And now the Jacobian in polar coordinates is going to be an r dr d theta. So the r is just going to cancel out over here. And now the theta integration is easy. So I'm going to have the integral from negative pi over 2 to pi over 2. The r integral is going to be a 2 cosine theta d theta. So I can pull up that 2. Antiderivative of cosine is sine. So this is going to be 2 sine of theta evaluated from pi over 2 to negative pi over 2, from negative pi over 2 to pi over 2. So we're going to get a 2 times the sine of pi over 2 minus the sine of negative pi over 2 or we could just do the integral in our head by looking at the graph of sine. That's 1, that's negative 1, so I'm going to have a 1 minus minus 1, so that's going to be a 2 times 2, so this polar integral is equal to 4. Thank you very much.